The final method that we'll learn for solving system is that of addition, sometimes called combination or elimination. The steps listed below show how to solve a system by addition. First, it's important to have all equations in standard form, which is ax plus by equals c. And then you need to multiply one or both of the equations by a number that's going to cause one of the variables to have opposite coefficients. So in other words, you need something like negative 3x on top and positive 3x on the bottom. We will then add the two equations and solve the resulting equation. At this point, one of the variables will have been eliminated, and then we'll plug the value received for the variable we solve for back into either equation to solve for the other variable. As always, it's important to check the solution in both equations to make sure it works. Let's look at an example of solving by addition. Notice here that this equation is already written in standard form. So our first goal is to cause one of these variables to disappear by making sure the coefficients are opposite of each other. I can choose to multiply this bottom equation by 2, or I could have chosen to multiply the top equation by negative 3. Both will result in the same answer. The top equation will remain the same in this case, and the bottom equation, I'm going to get 2x plus 6y equals 28. Now we'll add these two equations, which these variables cancel, and I'm left with 7y equals 42. Dividing by 7, I get that y is 6. Remember, a solution is an ordered pair that works in both equations. So I'm going to take y, plug it back into either equation. I'm going to choose to plug it into the top equation, and I have negative 2x plus 6 equals 14. When I subtract 6, I have 8 left, resulting in negative 2x equals 8. Divide by negative 2, and I get x is negative 4. Remember, our solution is an ordered pair, giving us a solution of negative 4, 6. We've already checked it in a sense, and it works in this equation. So let's check it in the other equation. We'll have negative 4 plus 3 times 6. We want to see if that equals 14. Negative 4 plus 18 does indeed equal 14. The solution negative 4, 6 works. As a second example, we have two equations already in standard form. Again, we need to get the variable to be opposite each other in one of the cases. I'm going to choose to multiply this bottom equation by 3, actually a negative 3, so that the y's will be opposite. My top equation is going to remain the same, and my bottom equation will become negative 6x minus 3y equals negative 15. When I add these, notice I end up with 0 equals 0. When 0 equals 0, that means it's always true. So there are infinitely many solutions. But I can write one in terms of the other. So for example, I need to choose one of the variables to just define. I'm going to let x be x. And then no matter what I choose for x, for example, here, if I now solve for y, because that's the variable I still don't know, I can subtract 2x, and I end up with y equals negative 2x plus 5, or 5 minus 2x. I'm going to write it as 5 minus 2x. And what this means is any x you give me, I can find the y that will work. For example, if I choose x to be 1, then y will be 5 minus 2, which is 3. This is one of infinitely many solutions that will work. So this is the generic solution that will work for any one. To prove that 1, 3 will work, I can plug it into either equation, and I get 6 plus 9, which is 15, and I can plug it into the bottom equation. 2 plus 3 is 5. Again, any x you give me, I can then solve for the y, and there will be infinitely many solutions.